There are 6 major topics in the MPM2D course. Linear systems is the first topic. This is where you have 2 equations with 2 variables, and these represent lines in the plane. We usually use x and y, so let's call it the xy plane. What you're looking for is the intersection point of the 2 lines, if they intersect. If they don't intersect, that's because they're parallel and distinct. We have a couple different methods of solving such a system. One method is to graph the lines, but if you do that, can take some time, and it also only gives an approximate solution by looking at the lines. You can solve algebraically by 2 different methods, and this always works and always gives an exact solution. You can use elimination, or you can use substitution. The second major topic of the course is quadratic functions. Now remember that a function is a relation in which each x value has exactly one and only one y value, which means if you look at the graph of the function, a vertical line anywhere in the graph will cross the graph only once. This is called the vertical line test. When we have a quadratic function, the shape is a parabola. The equation of a quadratic function can be written many different ways. There's standard form, there's factored form, there's vertex form, and vertex form is just an example of transformed form. In other words, it shows the transformations of the parent quadratic function. The parent is y equals x squared. In the chart here, I've got many ways of writing transformed forms. The last of the 3, this one here, includes a horizontal stretch, which is actually not in the regular MPM2D curriculum, but we have covered it in the 2DP version of the course. The axis of symmetry can be found using the magic formula x equals negative b over 2a. It can also be found by completing the square, but very few people would like to complete the square. You'd like to use negative b over 2a. To get the y value of the vertex, you would substitute in to the equation. The number of zeros, or x-intercepts, can be found by examining the value of the discriminant. The discriminant is b squared minus 4ac. We've been calling it delta this year. Next topic, quite related to the previous one, is quadratic equations. A quadratic equation has the form ax squared plus bx plus c equals 0. So very similar to the idea of a quadratic function. But when we are looking for the x-intercepts, or zeros, of the quadratic function, that's when we solve a quadratic equation, because it's equal to 0. Such an equation can have 2 solutions, 1 solution, or no solutions. We call these things roots. And we say that the roots are real roots if they're real numbers. The discriminant can be used, again, to determine the number of real roots. We can solve quadratic equations by graphing, but of course that requires you to have graph paper, and sometimes the solutions are not obvious. You may only get approximate answers. We usually solve them algebraically. Gives us the exact solutions if we do that. If we can factor the expression, and if it's easy to do so, we'll do that. Otherwise, we'll probably use the quadratic formula. This will always work. You can also complete the square, but most people don't like this method, and I would caution you against using it. Another closely related topic is generally called quadratic expressions, but really this is just working with polynomials doing algebra. The 2 major skills are expanding and factoring. Expanding is the process of multiplying expressions together using the distributive property. Always collect like terms and write your answer nicely at the end. A couple of special patterns you should know off by heart are the square of a binomial and difference of squares. Square of a binomial is bracket a plus b close bracket squared equals a squared plus 2ab plus b squared. Factoring is the reverse of expanding, where you take an expression which is in expanded form or written as a sum or difference, and you rewrite it so that it is now the product of two or more things. The methods we've looked at this year are common factoring, factoring by grouping, in which there's usually four terms and you common factor, and then common factor again. Factoring trinomials, and if the coefficient of x squared is 1, then that's generally an easy one you do by inspection. You just look at it and you write the answer down. If the coefficient of x squared is not 1, then we've been using the method of decomposition. And then there's factoring difference of squares. Another topic in the course is analytic geometry, which includes many different things, but usually relating to making graphs or sketches and working with equations and solving things that way. So we looked at straight line equations. We know that slope of a line is rise over run. We know that parallel lines have the same slope, whereas perpendicular lines have negative reciprocal slopes. We looked at the midpoint of a line segment. We looked at the length of a line segment with the distance formula. In some of the problems, we had to work out the equation of the perpendicular bisector of a line segment. In some of the problems, we looked at the median of a triangle. We also looked at the altitude or height of a triangle. And we also worked with equations of circles and ellipses. The last major topic of the course was trigonometry. We looked at similar triangles that have the same shape, therefore they have equal angles, and their sides are proportional to each other. We looked at solving right triangles using SOHCAHTOA, and we looked at the sine law and cosine law to solve any triangle. And that's my summary of the course.